And welcome back. We're going to get the morning kicked off with our second speaker. We just had a weather briefing from Dale Eck, the director of the Global Forecast Center at the Weather Channel. Now it's time for a winter weather workshop. Paul Kocin was here last year, and a lot of the attendees requested that they get a little workshop and asked for Paul to come back. So we're happy to have Paul back here. And if you remember, Paul used to be the winter weather expert at the Weather Channel. And so we have a little video here for you to take a look at, and you might see maybe one or two other younger faces on the Weather Channel. So let's take a look at this, and then we'll get started with Paul.
I think there will be periods tonight where the sleet will be going back and forth with snow, but I think the sleet will be limiting some of the accumulations directly in the metropolitan area. But on the northwest sides of the cities, it's still likely to stay all snow, but we're going to see that progression
Thunder
of
for
warming.
me, baby.
I'm trying, Jim. But I'm not trying that.
Our experts, our winter weather expert Paul Kocin joins us now to tell us more about what's happening currently and looking into the future for tomorrow. We could be looking at a major ice storm possibly, right, Paul?
Oh, this really has the potential to be a great ice storm across portions of eastern Texas. Oh, and the reduced visibilities, we need basically 3 hours of winds greater than 35 miles per hour. The winds have not been that high yet. And the question... Yes, I'm that raspy guy, and I'm afraid that the voice actually is still pretty raspy. I was here last year, as people remember, and the essence of my talk last year was actually a lot more fun for me, because I had to deal with the history of how we forecast these great winter storms and the changes that have occurred during the time that we have evolved, basically from the 1950s to the present. This talk is a little more of a challenge for me because what I've decided to do is really focus on one case. I tend to be sort of a pig when it comes to cases. I like to talk about a lot of them. But this is more of an exercise to deal with what do we do. I now work for the Weather Prediction Center at NCEP, so my job is very much tied into what you're going to see in this presentation. What we do is forecast the weather 7, 6, 5, 4, 3 days, 2 to 1. And during that time, we get an awful lot of information that we've got to process. We're also working with a group of developers in my organization who I'll give the credit to for really being responsible for a lot of what we see in this talk, to come up with tools that we can help forecast winter weather. And as just a start off here, I do have to admit, it has become what I would call a pretty frustrating process. Even though it's a process I love to do, there is so much information that comes in that we have to actually get to somehow decipher it down and put into a small enough package that we have to believe what we're saying. We're testing out the concept of ensemble probabilities. It's the latest. It's probably where we're at. And we're trying to show how this evolution continues to go towards a process where we're looking at so much data. The question is, can we simplify it to a point that doesn't actually drive us crazy? We are not there yet, but what I'm hoping to show is that at least we're in the process of going there. So to start off with here, the intent, rather than to show lots and lots of cases, is to use a recent winter weather event. Some of you will remember that, some of you will not. That can be good, that can be bad. If you remember it, I'm expecting you to join in, ask me questions, use your memory, and if not, I'm hoping to sort of say, this is what we looked at, what can we look at that may have helped this situation? And the process goes from day 7 to day 1. We actually have 2 shifts a day. That process is evolving. And to help generate discussion about what you would help forecast and what information that I'm showing, and I'm certainly only showing a small fraction of what we use, but what other information could actually help. There have been a lot of people involved. It's not just behind the scenes. These are people who are actively been involved in how to forecast winter weather at the WPC. Dave Novak heads the group. He's the one who's actually helping send us to the next generation of how we go from sort of the old process of how we forecast winter weather to where are we going in the era of ensembles. Keith Brill is actually somebody, I just like to point a shout out for him, is retiring at the end of the month. I have known Keith for the last 35 years. He's a brilliant mathematician, and he set up all of the computing process that we've done to help go from what is basically has been a deterministic forecast, sort of a big buzzword over the last few years, to something more in line with what we're now dealing with ensembles. Ensembles are the name of the game, and the real intent of my talk is to show where kind of we're at, just given one case of how ensembles, number one, obviously help us, but also to show like, whoa, whoa, whoa. We're generating these ensembles. They are not an ideal solution as of yet. So it's a work in progress, and that's where I'm hoping to kind of give you an idea. So to get a sense of what challenges winter weather forecasters face, I can show a lot of cases, but we'll stick to this one, because this one particular one, I did not know as I was putting this together what the issues were necessarily going to be. I actually worked 3 nights during the event, so I'm familiar with it, but the process is so intense that sometimes we have a hard time kind of stepping back and saying, okay, we have all of these significant weather events. Did we learn anything? How did we do? We produce a lot of stuff, and my job is really to get a sense of what are we actually getting at? How are the ensembles doing? What are they actually telling us? And that's some of the feedback I'd like from you. So we do a lot of statistics. They're generally based on storms that occur over a long period of time. We get generalized statistics. I'm coming from an area where I love the big events. I like the ones that kind of come to a surprise, or if not a surprise, or the ones that are even kind of tough to forecast. And I want to get a sense after these events are like, oh, we need to like hold on and get a sense, how did that work? Did we do okay? And I know after this particular case, this was the pre-Thanksgiving storm just a couple of months ago. You know, I got a sense of we did okay. Well, doing okay is a nice perception, but we've got to get a better sense, what does that actually mean? And that's what I'm going to try to get at here. All right, so it's going to be assess the promise, which for many people I think is obvious, and the shortcomings of the ensemble model approach. Now, fortunately, Bill LaPenta was here on Monday, and I was going to go through, I presented this last year, a discussion of how ensemble forecasts are made. He did a good enough job, so I don't have to do that. I can focus on stuff I like more. However, at the winter weather desk at NSIP's Weather Prediction Center, that's where I work, we're addressing the increasing role of ensemble predictions in the generation of winter weather and how that process is changing over time. So this will give you a sense of where we're at. I know all of you are also looking at many of the same things. You have your own forecast process. There is no one right process, but perhaps we're heading in a direction, we're not there, where that process might become a little simpler because there's so much information to look at. A simplified process might help us communicate better and to be able to come to terms with some of the problems we can with forecasts. What we do at WPC, and I'm not a big fan of like graphs that have lots of little bits of information, but this is going to be sort of, this is what we do. I spend hours looking at forecasts, trying to come up with, surprisingly, in the age of ensemble forecasts, a deterministic forecast. In other words, we got to come up with, like, how much snow do you think it's going to get? 4 inches? We have all these probabilities, but we still have to come up with a number. What's interesting is that all of you here do not see what we actually put most of our time and energy into. What we see is seen by local NWS forecasters. There is a good reason for that. Well, why don't you get to see that? I've struggled with that. The reason is this is the age of collaboration and consistency. It's a dictate from a guy I sort of know by the name of Uccellini, and it's actually a very good thing. We cannot be issuing, 6 to 10 inches here, 2 to 3 inches here. We have to have more of a unified voice. Otherwise, emergency managers, they're going to get confused and say, who do we listen to? Well, this is ridiculous. So we are heading in that direction of trying to collaborate and to be consistent more. And with 100 plus Weather Service offices, there's a lot of offices making their own forecasts that we have to collaborate and coordinate. That's not an easy job. However, we have access. I think the last time I gave this, we had 33 members. This year, we now have 58 members. It becomes harder as a human being to say, okay, I'm going to look at each and every one of those members, and I'm going to get a number. So what I'm going to show here is that if you try to do that, you'll get an answer. It's going to be wrong, unless you're very, very lucky. But what we include, the forecast that we make, this deterministic numbered forecast, is just one small component of what goes into this ensemble forecast. It's actually kind of important, but maybe I won't go through those because all of those other members, I think over the years, are going to change. They're probably going to increase. We may have more flexibility and say, you know what, we're looking at the SREF, take it out. I don't want that as part of the solution here. It's going to be very hard to dictate, like, okay, who do you keep in, who do you come out? Because Bill Apenta showed what he called this famous postage stamp representation. And if you looked at the postage stamps, he had a nice case where there was lots of clustering of similar solutions, but there were also several of them were like, whoa, they're on another planet. Well, if you actually looked at a lot of these ensemble members, the spread of solutions is enormous between you're going to get an ice day or you're going to get a big snowstorm. At some point, we're going to have to be able to put numbers on those possibilities and sort them out. Right now, we get a probability for the best solution. Later on, we may want a solution that's, no, we have a most likely solution, but there's a cluster of other ones. This one, maybe a second most likely or a third most likely. We'll have choices. And unfortunately, the reality of that's too, we can have a variety of more likely solutions. But as we saw in the Washington, D.C. area during the last week, we had a snowstorm due to a mesoscale band that really wasn't part of any solution. 2 days out, 1 day out. The good news was the night before, there was an indication that would occur. So if I have a chance and I don't ramble on, which I can do, I'll try to show a little bit of that case as well. It's interesting. So like I've just said, we produce a 1, 2, and 3 day forecast. The probabilities are produced by a deterministic forecast and an ensemble spread. So we can have some kind of range of what we're looking at. We also do track forecasts. We also do a heavy snow discussion. But that's not what I'm really here to talk about. The two main components we use are, again, the one I spend a lot of time in, that sometimes I get really PO'd because, I spend a lot of time on this, and then there's a 2-hour window of collaboration that local NWS people say, all right, we'll take a look at, and then they issue their forecasts. But the bottom line is we use that forecast on the top left to produce the forecast on the top right. a probabilistic solution, where if you look on the lower left-hand side, we're given numbers, if I get my cursor back, all the way from 1% to 95%, and you could see that the probability distribution, which takes into account our hard-earned, whoops, let me go back, deterministic forecast, eventually generates this probabilistic forecast. And they look similar, but they're actually differences. And those differences represent our forecast and 57 other members. And you could see what the difference can be. Look over North Dakota, Minnesota. There are probabilities for snowfall that our deterministic run didn't get. Why is that? There must have been a suite of models that we didn't buy into, but the whole suite of models said, oh, wait a minute, there is definitely a probability. This is why you get into trouble when you just go with one deterministic forecast. You've got to get an idea is that even though I'm not forecasting anything on the left-hand side for much of North Dakota, there are a suite of models that are actually giving you an idea that there may be a significant chance and maybe something we even missed. It also allows us to focus perhaps on areas where in the deterministic forecast, we're forecasting for an entire nation. Not easy to do. We've got 120 offices, but we can focus on where the high impact events we believe are going to occur. And since our forecast is not just one of 57 members, but actually becomes the mode of the distribution, it's got more weight than a lot of the other members that we do. We spend a lot of time. We want some credit. So that's how we kind of get into there, rather than saying, you know, I'm spending a lot of time on this. Why am I doing that? So we do have an ability to skew the forecast into what a human being believes, which I think is a harder thing that we're getting at as more and more models. And remember, we're in I'm an old guy. We're in 2015. We've got 150 ensemble members. Some people with a lot of time, you can go in there and look at all that information. The reality is that's just going to go up and up and up. As human beings, we cannot assimilate that much data in real time. So there is going to have to be work, which is why we're in this process now. It's sort of in its infancy. We can talk about ensembles, but even Bill LaPenta was saying before, he even asked me, I don't talk to him that much. This was a good chance. Do you think, you know, the more and more stuff we need is the idea? Well, my opinion is like, whoa, no, I'm a happy guy when I see a suite of models that like, I don't believe in. Thank God I have something I can eliminate so I don't have to drive myself crazy and look at all these different model solutions that are telling me all these different things. So we've got to have some simplification to get this there. I just want to say, you know, it's sort of interesting. I'm talking about a process. After hearing the talks yesterday by Jim Balog and even last year by Jim White, I was blown away by things that are, you know, really, truly important globally. This is snow. It's not quite the biggest issue in the world. However, in the markets that we're talking to, they can become really very important, even very small events. So I feel a little better. I just can't compete with you guys. So, and I appreciate what you do.
That's not true.
Well, I try. So anyway, most of you have seen this. We give our forecasts in 6-hour time steps for probabilities. We can change the duration, 24, 48, 72, 72 hours. And we can do it for various snowfall amounts. And that's where, you know, what are the probabilities that we're getting? 1 inch of snow, 4 inches of snow, 8 inches of snow. The unfortunate thing at the present time, just in my office, it's not a universal problem, and it's something that will be worked out, is that when we go from our deterministic forecast to our ensemble forecast, as forecasters, we cannot change. It's a bit of a black box right now. So when we are issuing these forecasts, I can't do anything about that. That's the way it is. And that can be great. There are times where I can't look at all this stuff, but there are other things where being specific. And that's where I think this talk will kind of give you an idea of kind of where we're at. You know, I think we're heading in a great direction, but there are still lots of kinks to be worked out. And kinks are to evaluate these cases as they occur and not just go, oh, that was good, that was bad, but look at the, the specifics. All right. Thanksgiving. Who here actually remembers that particular case? Because I figured some of you do, especially if you're on a certain part of the country. I know you do. I bet you do. And I'm sure on some level, I know you see a lot of stuff, Jim. This was a big deal. The big deal was that this storm was going to impact the I-95 corridor, where millions of people are getting on the road the day before Thanksgiving, one of the busiest travel days of the year. So the forecast itself kind of mattered. The problem was some areas looked like it was going to snow. Some areas also looked like it was snow, but it would be rain to snow. And we're looking at all this information to try to get a sense of where, in fact, that band of snow is going to occur. If it occurs inland, you're still obviously impacting millions of people. But if you're talking about DC, Philadelphia, Baltimore, New York, and Boston, well, the difference between not so much snow or not any snow and a significant storm when people are on the roads, that's a big deal. It affects decision-making. When do you leave? And in retrospect, this storm was difficult to forecast in some regards. Other regards were easy. The difficult part, unfortunately, focused on a very narrow strip where many, many millions of people lived and were traveling. So we had to deal with that. And we did. So all sorts of data sets we used. I can show you a whole suite of them. I picked a bunch of them. Part of the big problem I had, unless you collect the data as it's coming in, there's so much of it, you can't keep all of it. My problem with this case was that I waited a few days, and once I did, a lot of the information I really needed became then a research project, which meant I had to go try to find and collect it. Did we lose it? What kind of technical issues to get it back? I thought maybe I'd have the luck in the remaining time I'd pick a case where I could just be there, collect the data. That would make this much more easy. But I came up with it, I worked on it, and this is what I've got. For simplicity purposes, weather forecasts these days can be broken up into a medium range and a short range. General medium range still 4 to 7 days. Yes, we have the ability to look 10 days out, but in general what we do is 4 to 7, and then we go into the short range. The medium range forecast, we use ensembles, we use blends of ensembles, combinations of models. At this stage of the game, an ensemble mean is quite important, and we compare that against the many, many operational runs, primarily to see, well, compared to the ensemble means, which of the operational runs look like the means, kind of look like the means, or actually quite different. So the first kind of thing, without knowing if you remember much about this case, we look at what are called spaghetti diagrams. We can pick any number of fields, and it's a lot of gobbledygook here. But in your opinion, what I'm showing here, I'm sort of giving you the answer. The thick white line, let me show it in here. The thick white line represents, there's one particular contour That's what verified. This is a 7-day forecast on the left, a 6-day forecast on the right, and looking at the spread of solutions for that one contour, what do you think you can say in terms of if we're going to have a storm, snow or rain, where are we starting? What's the starting point that we have? Anybody?
Well, what the storm track's going to be.
Right. Well, I guess that's true. Yeah.
What is starting point? Starting point is cyclogenesis, starting point of...
Well, starting point, well, I'll get to that in a little bit. The starting point is we're dealing with a storm that's going to produce snow. If we have a trough and we're trying to replicate that in the forecast, how's the initial way we're looking at it? What are we looking at? I won't put you that much on the spot, because this is what we're looking at. 7 and 6 days before, we're looking at a trough that the models are actually telling us are going to be farther east than what actually verified. So the implication of it being farther east could be a number of things. The storm is off the coast, or if it's cold, the storm will be colder than the final solution may be. And that's because with the trough verifying west, that typically is a warmer solution. So that was the first indication that we're looking at the storm system 7 days out. It's possible. It started off actually as we weren't expecting anything. As we get a little bit closer into the event, there are some changes, but we're still out in the medium range, 5 days and 4 days. And what I think you'll notice with this is remember how far west that white line, not that white line, but this white line right here, is actually not as far west as, let's just say, the majority of solutions. 5 days out, 4 days out, it's getting even closer. So there is a trend in the medium range that we're trying to look at for a case that has potentially very high visibility. So to just give you a little more example, I can show you lots of fields. I'm not going to do that. But here is the ECMWF at that time. The day before, everything's offshore. Maybe it's 2 days before. I don't, there's so much data to look at, I don't remember. But this is 5 days out. So here we see a forecast where on the left-hand side, we've got a low offshore, and that goes from 1,012 down to 1,005. And I'm an old-fashioned guy in terms of forecasting. I still like looking at thickness. I know we got all these models with temperature profiles, and you can hear a lot of people go, well, I'm looking at the 900 millibar forecast from a given model, and it says the temperature is such and such. Great. All I see on this, I see one red line here going through. I live in DC. The thickness is 543. I like the 540 as a general starting point. It's not indefinite. It shifts back and forth. But at least it's something to focus you in, especially when you're looking at a lot of stuff. Yeah.
Dale, Weather Channel. It's interesting because we do kind of the same thing you do. We're looking at forecast on a national scale. And and you can inundate yourself looking at skew-T soundings. And I think, yes, if you are forecasting for St. Louis or you're forecasting for Paducah or D.C., those can be very valuable tools to really dig in and get into that. But when you have to kind of do a map forecast of where's the track of the heaviest snow,
right.
I still think those critical thickness values can really bring you to where you need to be much quicker than diving into all that data.
Soundings, right. Yeah. So I still look at, this is a process thing. It's different for everybody, but you got to start somewhere. And in these old sort of tried and true methods, you can't say, well, the 540 line is it, but it does give you a base from which to go on. And what you're going to see, the one on the left-hand side was for the morning of this day of travel, and the one on this side is 0Z on the 27th, later in the day. And what you notice, in this case, our thickness is marginal. It's 543, but it's close. There's a high over here. There's not much of a big high to the northwest, but you don't necessarily need that. But we've got a system offshore with somewhat cold air, and by the evening, we notice that the thicknesses are dropping, and we have precip sometime in the last 6 hours. There's a threat of snow. I will show another traditional map. I could show you all sorts of stuff. But you can look and see that indication that there might be snow. This on the left-hand side, whoa, moved really fast, and it's back. Excuse me. The blue line, or the edge of the blue, represents 0 degrees at 850. The first line represents -3. I, just me, have sort of a little bit of a rule of thumb that, when you're at 0, like, ooh, that could be snow, but somewhere in between there, it's going to be doing this on your sounding. So you like to have it a little to the left. And over the years, somewhere between -2, -3 gives you a little more room without having to go through all of the soundings. It's an estimate. As an estimate, let's see, how do I get rid of that? That's the correct time. Well, I won't focus on that. Did you hit escape? Thank you. By evening, as the 850 low is moving off the coast, it's going to -3. So I think the first indication is, yes, like looking at those spaghetti lines, this case from one model is showing the possibility of snow, but there also might be mixed precipitation. And since we saw those thicknesses dropping, there might be a transition. Transition zones are some of the most difficult things to forecast because changes in that zone and how it occurs is the difference between significant snow and like, oops, we didn't get any. But this was the issue 5 days out. We have a lot of room to update. And this is what I'm basically saying. This is a much earlier forecast. These are forecasts, matter of fact, very close in time, for the forecast sounding at Dulles Airport at a time that actually was crucial, where rain did in fact change to snow. And the only thing you really have to get from this graph, if anybody starts telling you, well, this particular model's starting to show, it's got the temperature below 0 at a certain time, it's like, well, let's take a look at an ensemble or a suite of soundings, and what do they show? They show gobbledygook. So, I guess what I'm saying here is that at some point in our future, we're also going to have ensemble averaged soundings as well, so we can at least have some probabilistic information on what the temperature structure in the vertical will be. And I think that's being done. But as individual forecasters, you can look at your 850, you can look at your 700. It's a jungle out there. All right, so 4 to 5 day forecast, the European, this is actually going to be pretty stereotypical. What do we typically know? And even, my boss's 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 boss before Louis is Dr. LaPenta, said the Europeans have been doing better. We are trying to close the gap. Personally, at this stage of the game, I'm just happy as a forecaster that at least there is a model that's got a reputation of being more reliable in the medium range. And there's a reason for that. They've put all their resources, for whatever their reasons, into that model. So that helps us. That doesn't say that we've got all of these suites of solutions that can tell us all of these ranges. At least we've got something that's relatively reliable. And I know it has not been quite as reliable this winter. In this figure here, precip amounts on day 4 and day 5 show the blue line, 1/2 inch, the light blue line, 1 inch, 1.5 inches. We have a significant precipitation event with rain-snow issues on the coast and snow issues inland. So we're already picking up, that's a problem. However, and this is not to put down the GFS, it's more just to indicate the complications we see every day. You know, it's wonderful when all the models come together, but now there's so many of them, the chances of them coming on a similar solution are becoming less and less. Who do you believe? Here is the GEFS. The GEFS mean takes the operational run and I don't know the number of other runs. If you look from, I guess it's 132 hours and 120 hours, the probability of precip on the GFS, the colors here, light green is 10%, dark green is 30%, chance of a ½ an inch or 1 inch. It's all, for the most part, offshore. So Europeans given one indication, the suite of GFS models is really saying, no, farther east. We have to deal with that. How do we do that? Well, we could look at individual operation runs. This is now a model we no longer have access to, for better or worse. This is the old GFS. And the old GFS, much different than the European, but it's got a trend. It starts off pretty far to the east here, big cities, nothing, day 5. And finally, it starts to come onshore, where by the end here on day 4, we're seeing the GFS moving towards that European solution. That's just what we're seeing. Now here's, and this is nothing to put down the parallel run, which as of yesterday is now the GFS. But it shows you, with all of these models, you still, that's the answer. Like I said, or maybe I told a few people, there's been a consensus amongst the forecasters WPC. We've liked the parallel run. We've liked what we've seen. It's a perception. It's a perception based on people working. It's not scientific. It's not objective. Let's just put it that way. I spoke to a fellow who I got a lot of these figures from, Jeff Manikin, from the development division downstairs, who collects this kind of information. He's not quite so convinced. There are times the GFS parallel did better. There are times it actually does work. With my interest in looking at the big events, I'm more interested in saying, okay, we've got the general specifics, it's doing okay, but how does it do? The answer to that is, I don't know that yet. And I don't think we're going to know that for a while. So you got to keep that. Here's our brand new GFS parallel. For this case, I did not pick this case to show that the parallel run was worse. I just picked this case because it was an important case. And this one actually did worse than the operational GFS. It goes from 5 days down here to 4 days. So as you're moving bottom right, left, upper right, upper left, the forecast actually from this on that day wasn't doing what the other GFS was doing. It was actually going in the opposite direction. It had finally seemed it was moving towards the coast, and then it moved it back out to sea. So now we're looking at European, big amounts of precip, the parallel run, nothing. This is standard operating procedure. Not for those runs, but what we often look at, day by day. So as we're looking, here's a 4-day GFS forecast. Now you can see the low. It's a little bit closer to the coast, and it's also deepening at a decent amount. So it goes from 1,007 to a 994. There's some indication on some solutions. This is a wave. There's also another indication on the solution. This could be a relatively big storm. The implications, if you have a little wave, precip may be heavy, but not, you get these nice big comma clouds. When you have high thickness and a big cyclone developing, you can get vertical motions, higher thickness, cools, places you expect to be rain and snow, more snow. So that's an issue. That we're starting to see in some of the models. So it's still a problem. However, if you look more closely and remember those 4 to 7 day trends on those spaghetti lines, the thickness now, which was 543, is going up to 546. Yet we're still getting information that a lot of that is snow. And it's still changing back. And if you look at the shape of the precipitation, it's kind of got that little comma appearance. You're more likely to get the big snow in these nice comma head systems. 850s, almost unchanged. Still starts out near or below 0 and goes to about -3. I can also show you the ensemble means, the Canadian. This is all stuff we do look at, if not more, and more fields. I'm not going to. We also have another tune, another product that we're trying to generate. Most of what we do is days 1 to 3 for snowfall, but with ensembles, we're also trying to do days 4 to 7. We're forecasting the probabilities from ensembles. Right now, it's in test stage. I don't think it's available yet. The idea is that when we see that it's useful and we've tested it, then it becomes a public product. What are the chances for basically getting an inch of snow or more? This is a lot of work that a fellow by the name of Mike Bodner is working on. You start out with sort of what is the probability of greater than 1/10 of an inch of precip, say it's day 6. You compute that. What is the probability that whatever precip, whether it's going to precip, would fall as frozen precip? You combine the two, you go all the way from the left to the right, so I just showed you 1, 2, you come up with number 3. What is the probability of winter precipitation greater than 1/10 of an inch? That could be freezing rain, that could be sleet, but it also would represent an inch of snow. So it turns out that's actually the winter weather watch for this particular case that went out the day before. The forecasts that we have for days 6, 5, and 4 are the following. And you can see on day 6, 5, and 4, we got probability forecasts. How good are they? Well, we don't know that at the time, but in retrospect, it's providing the scale just on the left-hand side, 10% chance, blue 30%, dark blue 50% chance. On day 6, there's a 10 and 30% chance. Day 5, the same thing. Day 4, we're starting to see a 50% chance of greater than an inch of snow. What we think by seeing something like this, well, the probabilities aren't great on day 6. They're not great on day 5, but they do point your eye that there is a probability of getting at least an inch of snow. And it's in kind of the right place, but it's small. Why? Because it is day 6 and 5. You're getting all that information, and that information says there's only a chance. It only is until day 4 that we start seeing probabilities greater than 50%. When you see a probability of greater than 50%, you think, oh, there's at least an even chance that this is going to happen. Well, think about it. You're out at days 7, 6, and 5. The models give you a range. The system may not happen. What do you want to see? I kind of would like to see a small, not a 0 probability, but a 10 to 30 plus indicates, there is a chance of snow. I don't know if it's not definite, but there is some. By the time we get to day 4, then it becomes more, now it's beginning to look real. Then we can really get something. So, summary of the medium range is potential for East Coast storm appears around days 4 and 5. Before that, really nothing. The threat is initially offshore. There is this battle between two forecast systems, basically looking at heavy and light, colder, maybe not so colder. Some threat of the snow for big cities and inland. It's less than 50%. Now let's move on to go towards the short range. Does it get any better? You'd like to think that most of the time it does. The reality is, when it comes to the short range, the amount of information coming in makes me feel primarily like these two guys. Kind of want to scream. There's so much information coming in. I can go on, and I listen to some of these other talks. We're doing this, we're doing that, we're doing this. You can look at all of this stuff, and we do. I start feeling crazy at that point, but you still have to make some solutions. But let's go back to what we mostly use in this process. European, not showing quite as this is a 2 to 3 day forecast. Still a similar solution. European is actually now a little bit farther west. It's got the low 1007 near the South Carolina coast and 998 off New Jersey. That's 12 hours, and that's about 9 millibars. A good development. We like to see 20 millibars. That would be fun. This one wasn't in that class, at least from this forecast model. But we can also see that thickness-wise, again, there is a trend. And again, remember back to what we were seeing with the medium range. Thickness now 543, 46. In DC, it's 549. Continues to warm, yet it still continues to cool as precip is falling. But we can look at the European. There hasn't been that great. There's a little shift to the northwest on the 850 temps. And we could look at the GFS. The GFS, if you look at it a little closely, the thickness, it's lower. The GFS has been farther east, but it's moving in that direction. But at least the GFS is now showing significant coastal storm. Nothing explosive, with a temperature, a similar 850 temperature distribution. To drive ourselves even more crazy, this is where I'll try to inundate you briefly for a little bit. We can look at the NAM. The NAM at this point has significant precip. It's not that much from the GFS, keeps the heaviest precip off to the east. We can also look at the SREF mean. The SREF mean is the NAM and all these other runs. It's a little bit farther to the northwest. We can also look at the NMM, which is part of the WRF system. It's a separate model. It also has a relatively, coastal solution. It doesn't extend very far inland. Or we can look at the ARW. This one actually was a better forecast as far as what actually occurred. It extends it farther to the north and west. So I'm going to end this particular aspect with a view of we make our deterministic forecast, which for us is our bread and butter. It's not your bread and butter, but it's our bread and butter, where we indicate one forecast. We can't show you this, but we can at least give an indication. Here's a close-up of what we were thinking by this time, given all of that information we were looking at. And I work it, other people work it, everybody comes up with a different forecast. But at least on this day, and I'm not going to show you a forecast I really stunk at, but I got an ego too. That's probably why I picked it. It turns out it wasn't that bad. But there were problems. So here is, the light green is the inch line, the dark green, the middle green is the 2-inch line, the darker green is the 4, 6 blue, 8, 10, 12, 14, just to give you. And I'm only asking you to focus on a few places. It was really important to me anyway, and others, that we get this forecast as right as we could. And notice everything is occurring in that little narrow band. At this time, and this was about 2 days before, it looked like we were going to get, from my estimation, 2 to 4 inches in the area, 1 to 2 Philadelphia, 2 to 4 New York. Boston I didn't show, but it was about 4 to 6. But we had, there's a line that defines the axis of the heaviest snow. We would like to show that. Looking to southern Vermont, we're forecasting over 10 inches. This actually is the deterministic is on the left. We spend a lot of time. We then send out the deterministic. The local offices look. They give us ideas. We might make changes, we might not. And then we go through a process where we run basically some black box forecasts that determine, Keith Brill has worked on this for years. It's a good system. But it also points out, you know, we don't even see this. This is actually the last thing we do. We send it out and we can't verify it. Well, it's not that we can't verify it, we can't edit it, we can't change it. This is automatic and it's after we've already worked. So as forecasters, we're already kind of done. You know, we don't have any control over this, and this is what we sent out. And my biggest issue is that these are the forecasts that all of you wind up seeing that we don't actually touch. Personally, I don't like that, but we're working on ways to make that a little bit different. But I'd just like to point out some things here. You know, in general, you look at it, it looks pretty good. That's not surprising. When you add 57 models and you get sort of an ensemble suite, you want to see what the range of the solutions are. It's interesting because I'm going to tell you in a bit that in Washington and these big cities, we got less than an inch. The probabilities that were produced by our system for 1 inch plus, not too bad, but you also notice the blue line here, I wish it represented 50, it only represents 40%. There was still not a trivial chance, if this is what you're looking at to make your forecast, and not a deterministic forecast, that there's still a 40% chance of 1 inch of snow with all the models we're looking at as far east as southeastern New Jersey, Chesapeake Bay. That obviously is a little bit overdone. In the cities themselves, there's a 40 to 50% chance of about an inch of snow. And that even goes up towards Boston. So this is actually where it's going to work the other way. That's not a bad forecast or bad probability. You know, if you see a probability of 50% that it's going to snow an inch, well, an inch forecast sounds pretty reasonable. However, if you look up in Boston, my forecast was like 4 to 6. This one is basically saying there's probably a 40 to 50% chance of 1 inch. This is an area where it can help, and it does help. But if you look at, on the right-hand side, now we're looking at the ensemble probability of 4 inches of snow. We still have a pretty good shot, 40 to 50, if not more percent, all the way up the corridor. It's still showing us with a chance 4 inches is reasonable. It's saying in Boston, not reasonable. And it's saying even in southern Vermont that it's less than a 50% chance, which is really quite a different forecast than our deterministic. Here's 10, 12 inches. It doesn't even have a good chance of 4 inches. So what I'm trying to say, the ensemble forecasts, if you look at them, provide good information, but also provide information that ultimately can mislead. And it's just sort of reality right now, just to kind of let you know. Because we often do not go through that exercise after we issue the probabilities, like, well, what do those probabilities actually tell us? You know, did it give us good solutions, good choices? Some places, absolutely. Other places, who knows? So we're still at a very evolutionary point. You know what, I think I'm going to probably skip through as we get closer to the end because we're basically looking through the same thing. And I want to get to this January 6th case because it's recent. Howard Bernstein made a great little comment I'd like to show. and just kind of points to the reality of what we do in real time. I will show this particular couple of graphics. Rain, snow, snow to liquid ratios. There's something typically we kind of like think about. We've gone, well, maybe it's 10 to 1. If it's really cold, it's 20 to 1. Well, there are actually a lot of people in my group as well that are trying to institute techniques which give us a better, this is a snowfall forecast from these techniques. It's called the Roebber technique. And, you know, I'm not even sure about the time it was issued, but it gives us an aid to say, okay, what are all these different models telling us with how much snow? Give us a number. Well, current thing is that number was relatively high there. We're also working on techniques that I don't really understand yet all that well that is supposed to reduce or influence the amount of snow in transition areas, called this rime factor. And one thing that's really nice in this particular example was that the rime factor really reduced the amount of snow from some of these more other techniques. So that's where we're going to be looking at in the experiments that Dave Novak has been running for years over the next couple of weeks. And this is provided by Jeff Manikin. 15Z on the morning of the 26th was this time. We were looking at the 850s, and there was a time things shifted. If there was going to be a change to snow, this one was it. There are schemes in place. This is the NAM rain-snow line, indicating it, you know, that's a pretty good forecast. So now we're looking at all these other models. NAM out at day 3, maybe not so good. Day 1, sometimes pretty good. GFS, also fairly similar, but it's a little warmer. You'll notice here over time, these are forecasts in time. That was interesting, it actually worked. And here's the parallel run, and consistent with how it did for this case, it's too wet. And on the right-hand side, you can see where the snow and the rain are occurring. And we have access to the rapid refresh, as well as the high resolution rapid refresh. You know, we can see the output from that. And at 15Z, we are right in the transition zone. So we're looking at all these models to kind of help us with it. Here's day 1 and 2. We've diminished our snowfall amounts. Here's the one I did on the left. Here's the one we worked on the following day. And if you look more specifically, we're trending in our forecast with all this information slightly less snowy. So rather than 2 to 4 in DC, DC is now, this is DC right in here. We're basically saying 1 to 2 in the northern suburbs. Same all the way up to Philadelphia. New York, we still got 1 to 2. Boston, we're still probably overdoing it. We're still forecasting a lot of snow in New Jersey. It's deterministic, and then black box, we're done. We issue probabilities. Still high probability, the 50% line for the probability of an inch southeast of DC. So it's still predicting, you know, not serious amounts, but a few inches. Philadelphia, 1 inch. New York, probably a couple of inches. Same thing in Boston. There's a good chance in southern Vermont. We're extending it farther northwest, but still even in southern Vermont, a pretty decent amount. I don't want to focus that much on that amount. And then on the day 1 forecast, our deterministic has DC with less than an inch. And basically an inch, 1 to 2 still in Boston, inch or less Baltimore, Philadelphia. So we're sort of in the ballpark. So to finish off with the short range forecast, the storm was predicted fairly consistently, days 3, 2, and 1. The transition zone on I-95 was an issue. The trend was towards slightly less snow. The resulting ensemble forecast may have slightly overstated, slightly, really, that's, you know, it's not a huge difference. But if you were to look at it and what you got off of it, slightly overstated it. However, as the event approached, our organization suggested that the snowfall threat along the coast would be less significant. So the early model forecasts suggested that heavy snow was possible, but wasn't really likely. 6 to 12 inches was the general consensus for the max areas where it fell to snow, but uncertainty throughout the forecast always remained an issue on the coastline. What actually happened? The impact of the event still resulted lots of flight cancellations, 400,000 people without power. They just weren't in New York, Philadelphia, DC, and Boston. Huge travel hassle for road and air travelers, but not an incredible one where you really don't get an idea from the media, sort of like, well, how bad is bad? Well, I think we dodged a really big bullet by having at least the bulk of it in the most heavily populated areas. Snowfall totals, I've probably got a better Weather Channel, thank you. But I'll look at it from a scale that I typically use. If you remember from last winter, February 11th to 14th was kind of our big storm. It was after our conference. By the way, we had a really good winter up north. It was really good. On the right-hand side, the NESA's scale, which basically takes snowfall, area, and population. Higher the number, bigger the impact. Lower the number, less impact. That one we had in February, big area of 10 inches, right through the major metropolitan areas. To change terrain, it even went back to snow. Now that was kind of a big event. If we look in retrospect at November 26th, look at the area of blue, much smaller. The white areas represent 4 inches or more. As a result, the NESA's scale gives it a category 1. Still a big deal, nowhere near as big a deal as what we saw in some of these other storms. Howard.
Paul Howard, Birds at WSA. There were some totals like in Augusta, West Virginia, not far, about half hour west of Winchester, Virginia, and some of the higher elevations that were in the 15, 18, 20-inch category. And so you showed Petersburg a minute ago. How is a forecaster, or is it even possible as a forecaster, to have an indication that you're going to have something like that, or is it just too small scale at this point and these things just happen and we have to accept it?
Well, all I know is from the forecast we issue, you kind of have to accept it. If you have a very low probability event, you still have to come up with a deterministic forecast.
Do you think the models have enough topography built into them yet to come up with some of that?
They're starting, yeah. The question is whether or not they predict it in the right place. I don't think right now we've got that specificity, especially when it's a small area. And if you look on this particular diagram, the area that received all of that snow, relatively small. So that's not easy to forecast. And actually, if I went through, showed, we did have an area of 8+ for there.
Paul, real quickly,
yeah.
I think, and answering your question is, with the higher resolution models, and we're seeing this a lot more. We've increased the resolution of our even ensemble model, if you will. What you saw there in West Virginia, that's where snowshoe is. And those things are showing up, and they actually are real, and the models are starting to give you that real, it's not like, well, here's the general, and in the mountains you're going to get a foot. I mean, they actually are starting to.
Well, and I get that, but we're at a point.
But you get these mesoscale bands in a synoptic system. No, they may
I think
try.
that's what happened because the blue on the map on the left isn't even in the area. It should be more toward the east, more toward the Virginia state line.
Okay.
Yeah, I'm just saying. I think, but I think what I am seeing is the models are picking up the orographics a lot better and are very helpful there. And I think what Paul's going to say, which is, and you said this back when you worked at the Weather Channel, someone's going to get more snow than you think, and it's going to be the place you didn't expect it to happen. You get these bands that set up, and they're
Right.
very hard to predict,
Right.
and the models don't have.
And
much
we have
skill in that.
arguments all the time at work where, we're trying to go with the models and we're trying to coordinate with the QPF, it's really very hard because the models specifically, with all of them around, you just don't get that kind of detail. It may hint at it. I have to forecast for the western U.S., and
That model's doing a great job. I'm just going to let it go.
well, it's funny. I mean, we look at what's called the NDFD, and I compare there nicely because they work in those areas. Oh my God, the kind of detail they get on that, we have to have, and right now we don't. So we've got to figure out a way to get those kind of details. That's not even due to mesoscale banding. That's just local effects that everybody in their local area knows. So that's the same thing with you in, Western Maryland. I've got a little better map here. I didn't do it. But some guy really puts together some really high-resolution maps. So getting back to this case, this is our big snow-changing terrain. It's a technical term. I do that a little too much, I think, but it was puny. But if you go Newark, IAD, they're on the west side. Yeah, they did get 1.5 inches. So that transition zone, maybe it was 20 miles off, 30 miles off. In the scheme of reality, that's a good forecast. In the jobs you have to do, that's a yucky forecast. I don't see a real big solution anytime soon, but I can be surprised. There was real snow. This wasn't the storm of the century here. 10 inches in Binghamton, Albany, and Concord. But it is Thanksgiving. It's early in the season. Those people have family that are driving too. There just aren't quite as many of them. That doesn't negate the seriousness of it. What I'll get to a little later is that forecasting this snow was a piece of cake. Sometimes in the same forecast where you've got areas that, like, oh my God, I don't know what's going to happen, but you can have another area where day after day, the chances of something significant, that's a great forecast. So every forecast, for the most part, has some areas that are good. Great forecasts, but other areas, these are the challenges that exist now. They existed before. The probabilities are here. Sometimes they're helpful, and I'll show in a little bit, if I don't know how my time is running here. They'll do out. I'm not going to, they won't get it. It will be information that is not useful. Okay, this is just a verification. 7, 6, 5, and 4. These are the products we produced. Day 7 and 6, looking at all of our information. Nope. Nope. Here it's starting to look, the pressure lines are being a little more convex than concave. And here there's definitely a low off the southeast coast. This is just because this is the morning of the 12th. It's a little slow, obviously. The low is actually farther north. By 0Z in the day, here's the analysis satellite. It had deepened to 997 off southeast New England. Here's our forecast in advance of the same time. You can see the positions are not great. That happens. But at least the indication, day 7, day 6, nope. Day 5 and day 4, the storm is moving too fast, but there's a storm. And here's the snowfall analysis that maybe will be better for Howard. I have to find out who this guy is because I spent years doing these maps, which I don't do anymore. And then I see this and it's like, oh, it's a man after my heart. Has very smooth, nice, contoured analyses. This is what we need after individual events. And I guess, Howard, let me ask you this. This area here, does that look reasonable?
Looks much more reasonable.
Great. Okay. And here, this kind of distribution, I'm just going to show how did our deterministic forecast, just for the hell of it, compare to the actual snow. This is really where You know, did we capture it well? You can get a sense of that. I haven't gone over it with a tooth and brush, but you can see in reality all of our forecasts underpredicted in southeast PA. The 4-inch line made it all the way up to Burlington, Vermont, and it went this far west. In general, you look at it, yes, the emphasis was a pretty good forecast. For all of you specific forecasters here, some yes, some not so good. If you're in Harrisburg, you had to deal with, we overpredicted. Same thing as we get down to day 1 to 2 and day 1. Our forecasts were getting a little better, but some of the same issues. You know, we got the forecast, slight over prediction for the I-95. Over prediction, well over prediction in southeast PA, under prediction in West Virginia. But the northern extent, not too bad. 12Z, radar data, surface obs, it's warm. Boundary layer temperature for this storm was very important. It started out warm. The only way we weren't going to be advecting this lovely 35-degree air from central New York, the only way we were going to get cooling was from a loft and heavy precip. It didn't really occur. You can see that at the critical time, that big yellow donut over us, of course, is the melting zone. There is some heavy precip, heavier bands to the north, but you'll notice temperatures through Pennsylvania, even in Maryland, have come down. So some of that ascent, better vertical motions, cooling is occurring. That could have continued. It didn't. It actually looked like some of the precips sort of broke apart. This wasn't the biggest storm in the universe. It didn't have that great comma head hanging back. So we were sort of stuck in the rain-snow mix. You know, this wasn't that storm that deepened 15, 20 millibars and had all this incredible vertical motion and just heavy snow broke out. It was okay. And it just goes through the end. All right. I've talked about the case enough. I don't think I have to go through this in the 6 or 7 minutes. It's not actually the end, but this is a picture of the White House on the 6th. So, and I like being able to apply things, kind of things that, we can remember. This just happened. It was interesting. I'm not showing the NWS forecast. This is from the Capital Weather Gang, which really reflected a lot of, I think, the current thinking of what was expected to happen. 2 days before, it was all going to be to the north. The day before, 1 inch to 2 actually started, it's coming south. Snow arrives before dawn, continues to midday Tuesday. The one thing that was really important about this case, my first day at Weather Channel involved first days. I remember hearing of a trace of snow in Washington, but it hadn't snowed before. They had a 1/2 inch of snow, and it was 14 degrees. The roads were not treated. It was unexpected. Kids were left home from school for less than a 1/2 inch of snow. How serious can this be? Well, as we saw in Atlanta last year, if you don't treat the roads and it's cold, cars generate heat. They're heavy. They exert a little pressure. Stuff melts quickly, refreezes. Disaster. This was with a trace of precipitation. In this case, the temperatures were supposed to fall down, not to 14, but under freezing.
20, give or take 2 or 3 degrees.
Right. That is cold, and it hadn't been snowed really before that they needed to treat. So, this is what happened. Snowfall amounts in the area, few inches, 2 to 4, up to 5 and 6 in the western suburbs. In general, 2 to 4 was probably a pretty nice call. Snow overachieves. This is from, I guess, Channel 7. I like to use that word even though the atmosphere doesn't give a overachieve, not doesn't care. But it overachieves in terms of expectations. Howard, for their terrible calls, I just wanted to put that in there. However, this is the impact, and I'm sure most of you are familiar with Google Maps. If you live in a metropolitan area, you check this before you go home. This is the impact that morning. Howard.
I had a conversation with the guy from, one of the state highway guys in Maryland, who I know a little bit. I called him up a couple days later and said, what happened? What was the problem? Well, the salt trucks were out, but they got out in the morning rush with everybody else.
Yeah.
And they can't spread the salt if they're not moving, because none of the traffic's moving. So unless they get out ahead of it, or unless people stay off the roads, because people are saying, where's VDOT? Where's Maryland State Highway?
Right.
Well, they were stuck in traffic with everybody else.
But this was still a forecast of 1 to 2 inches on a
Well, that's a separate issue, but
Right.
if you're wondering why, or some people wondering why the roads were as bad as they were, well,
Right.
the commuters get in the way of the highway crews spreading the salt and doing their jobs.
I think this is a fairly common issue every winter, everywhere. But the difference between our 1 and 2 inch forecast and our 2 to 4 that really happened, a little mesoband. Did we forecast it earlier in the week? Couldn't. System actually looked in a bit like a dying quail. It was coming east of the mountains. But, the atmosphere doesn't know it's totally dying. And this was basically, could have been one of these bands that start and lasts, but it was just a band that lasted for about an hour, hour and a half, came through and made a 1 to 2 inch, a 2 to 4 inch. Here are those same probabilities I show 2 days in advance. So probability of 1 inch, this time I'm changing it, no deterministic forecast. The probability of 1 inch, 2 inch, and 4 inch. 2 days in advance, the probabilities of where it happened, very, very low. Matter of fact, for 2 inches plus, the probability is, if you say, less than 1%. That's not telling a very good story. 1 day advance, we saw was coming down, but the probabilities telling another story, high probability, 60, 70% chance, 1 to 2 inches, 1 inch plus, 2 inches plus, now we're going down to, if I look at the scale, it's like 20, 30%. 4 inches plus, Dulles at 4.2. There was a whole bunch of places that had 4 and 5. With this system, less than 5%. The good news, this is the bad news. The bad news, this is the 95th percentile of all the forecasts. In the highest probability, you might expect from this event 2 to 3 inches made a day in advance. So, that's, if you're a forecaster, you got to be nuts to go higher than that. That's the end. But, and there were snow to liquid ratios to deal with. Mesoscale models. Well, even things changed the night before. Even the Euro mean is indicating a nose of solutions of greater than 1/10 of an inch. With low snow, with high snow liquid ratios, that starts to add up. You can't be that specific to go, well, you can try to be specific, but you can try to look at, well, it's going through Montgomery County. That's only 0.08 in DC. Well, you do your best. But then the SREF's picking up on significant, and then here's a combination of a lot of different things. It's called the SSEO mean. It's a bunch of WRF, other models. Suddenly we're indicating, even in the area it's not located, greater than 1/4 of an inch. This was an indication that, that probability of less than 1% might be, and I don't have the figures, not so good. The HRRR, also 3-hour QPF, this was made a few hours before the event. It's actually quite a revealing forecast. 6 hours before, if you follow the evolution, you will see it had very little chance. The system was forecastable within 6 to 12 hours with a little higher probability. The information was there. So this is in general what happened. 2 to 4 inches between 9 and 15 Z. Temperatures in low to mid-20s. Snow stuck immediately. 1 to 2 was forecast. We really had 2 to 4. Wasn't so bad. First real snow of the season. If it hadn't been for that little mesoscale band, excellent forecast. First snows of the season can be dreadful, and some schools, as Howard pointed out, made poor choices. So I'm going to not go through that and basically say, I'm done. Thank you. And my voice held out.
Paul, thanks very much. What we'll do is open the floor now to questions, and it's great that we have these interactive discussions while Paul was doing his presentation. I think that's really adds a lot of value. So we'll open the floor for discussions. Please, as a reminder again, use the microphone. If you don't have one, just raise your hand and I'll bring one to you. And those of you online, there's been some Twitter discussion online about some certain items. If there are any questions, then Sarah Perfader, our social media producer, will ask those questions as well. So start off with Dale and then Howard.
Yeah, Dale from the Weather Channel. I do that last case remember it very well. The forecaster sitting there, and I'm seeing him sending emails going, I'm up in the snow, and it seemed like it was related to, if you looked at the synoptic models 24 hours in advance, you definitely had a distinct clipper coming along that's going to fizzle as it's, exiting. And the forecast through the Ohio Valley was good, and you're looking at 6 and 12-hour data, couple 2 days, 1 day out, and then it did what it was supposed to do in the Delmarva. It fizzled. And I think what ended up happening was there was a pretty sharp temperature gradient, like going from 20 to 32, 33. And something fed off of that. It seemed like it was even a little bit of warm advection that helped enhance that band that was there. And like you got the little bit of pivot too. So you got a little warm advection band, and then as the storm's exiting, you're kind of on the. It wasn't a classic calm ahead. The thing I guess that bothers me about these kind of events is the human nature has turned to, I have to blame somebody for this. Why can't it just be, we got some unexpected snow and some people were inconvenienced, and to more than that. I'm not saying if it's you that's stuck in the car for 6 hours, or it's you that's walking on I-285 in Atlanta last year, or on the road for 24 hours, that's definitely more than an inconvenience. And I really felt bad for the public officials in Atlanta. I mean, I've lived in Atlanta 28 years and have never seen it, except for once, just snow at 22 degrees in the middle of the day. Typically, it's always marginal, 30, 32. It's wet for a little bit. People panic, leave, and by the time it really gets cold enough and there's a lot of road problems, people have made their way home. I mean, I remember looking, and they're hammering the mayor. You guys blew this, and how could you send the kids to school? The forecast was for 1 inch. It got 2. It wasn't a completely blown forecast. It's just sometimes in life, you experience things for the first time that you haven't seen. And a lot of bad things can happen from that. But this immediate, they made a bad decision. These guys made if they were thinking, they would have done that. The forecast wasn't a great one in D.C., but you learn stuff from going through that, such that I think the next event, and we did it in Atlanta, I remember I was having carpet put in, and I'm sitting there going, why are the kids home? It's raining today. But because they blew the first one, it bothers me that there's this, people are human, they're going to make mistakes, and we know in this business, our forecasts are going to be far less than perfect, and I think you could go back, and you could say, well, if you had done this, it would have, but sometimes things just happen that aren't expected, and people get caught in bad situations. So
and you're
that bothers me a little bit.
Bernstein, WSA. And I was one, if you're not aware, I called out some of our school systems for not closing. It started snowing. We had a reporter in Leesburg, which is in Loudoun County, at 4:30 in the morning. Loudoun County doesn't pick up their first student, as far as they told me, till 6:50. Their buses have radios. It was pretty obvious by 5:30 the roads were a mess. For whatever reason, whether they didn't recognize it or they were afraid to change direction, they did put everybody in jeopardy. And I know they're human, and people make mistakes, but when you don't recognize that, when you have the responsibility of the safety of the students and the faculty and the bus drivers, and you go forward, come hell or high water, they do need to be called out. They do need to be woken up, and they do need to be challenged. And the problem that you were saying is, yesterday there was a dusting of snow. So Fairfax is one of those districts that didn't close last week, but they did close for a dusting of snow. So they're afraid of their own shadow. And I would tell any of these school systems, you have to treat each event as an individual event and have amnesia so that you're not biased to do one thing because you blew it last week.
Sure, and some people might have made some bad calls, but I think, to think about, and again, you go to bed the night before expecting a certain outcome. And I don't think people's alarms go off when the snow starts. I mean, there's things that you get to a point where, and I don't think they said, hell, we're going to school. I'm not turning back now. Sometimes you're just caught off. I mean, it happens at the Weather Channel. A big event happens, and when people, all of the operations area is not expecting it. The forecast was blown. It takes you a few hours to kind of get your feet back underneath you to then say, okay, now we've got all good information. Let's make the call. So I think it's a tough situation. I'm not saying that some people didn't make some mistakes. I just think our society has gotten to where anytime there's, in the weather, something happens, it's like we got to find someone to blame or we haven't done our job.
Dale, Joe Murgo from WTAJ, I think some of the blame goes is these people aren't listening to us all the time when they're in the rush in the morning. They grab their cell phones, and the cell phones aren't talking about a changing situation. They are still going off of the last model. They are not going off of radar observations.
Yeah. We make a forecast. They blew a nowcast.
Well, I think there will be a fight in the halls. I will sponsor that. There are different ways of looking at this, and I think what I was trying to show in both these cases, that all of our forecasts, the chance of them being totally correct, whatever that is pretty low. And the reality for the January 6th case is that there were lots of different factors. Our forecast, I wasn't working, I thought actually in retrospect, pretty good. If it's a 2 to 4 event that was 1 to 2, the difference between a good forecast and a bad forecast was a low probability event. That happens all the time. Now, how school systems get their information is a far different issue, whether they've got private services, that's a complicated issue that's going to change on a case-by-case basis. I like the fact I was able to present a case where for that one case, the rain-snow line was the big issue. For the January 6th case, that one little mesoscale band in the one place was that issue. That happened to us in DC where we know it. This happens everywhere, every time there's a winter storm. So we do have to, we can't totally be as critical. The forecasts sometimes are good or not. We've got so much information coming in. You tell me how we're going to be that correct. And it depends very much, is it 7 days in advance, 1 day advance, 2 hours in advance? It's a really complicated problem. And I think the two of you shouldn't fight it out.
Jennifer Okavina from Paducah, where we also had a very minor winter event this morning, but it was one of those where, 20 miles makes a difference, and it wasn't exactly 22 degrees, but they didn't pre-treat. They just did bridges and overpasses, and we got about 1/2 inch to 1 inch of snow across portions of western Kentucky, and there are accidents everywhere because
temperatures were
28.
Yeah, that'll be a problem.
So treatment probably would have worked
Yeah.
had they had done it, but then model forecasting was also about 50 miles off. So, and it didn't show the little band that set up that gave an enhanced even 1 to 2 inches in parts of western Kentucky, which was really forecast to be across southern Illinois, which for whatever reason in our area, state boundaries just stick. And so if you say anything about southern Illinois, everyone in Kentucky just not even listening. But so anyway, what I was going to mention though, and I've been waiting for this moment this entire conference.
Yes. Jennifer, would you like to get up here?
No. And it's hopefully going to provoke discussion amongst all of us, because you and I talked about this a little bit yesterday, and Brad, you were there too. This trend of meteorologists is what we call them.
Meteorologist.
These people that are at home, maybe they have a little bit of weather experience, but they don't have the education, and we've got people at home that have 30,000 followers that are putting out information 7 and 8 days ahead of a winter storm, and that's what everyone latches onto. And so me and the weather team at home, we kind of have a policy, it's 24 to 36 hours before we hone in on totals, because that's just irresponsible to put out, you know, whatever the GFS is saying 8 days out, which we know is going to be massive. How is everyone
Even the
else
Euro.
combating that? Because it's very difficult to overcome 30,000 people and social media right now. I mean, how is everyone else dealing with that? I try to ignore it, you know.
Out, put a first call map up and say this is the first call, and then second call or final call.
You say call them out? Is that what you're saying? Oh,
The first call. It's my first call guess
oh.
versus the second call.
Well, we do that, but it's
They focus in on that no matter what.
they put out a map.
Word guess. Yeah.
They put out a map, and what they do is they put out the 95% of the, you know, worst case scenario. They don't put out what is logical or what is closer to average for what we see.
I think you stick to your guns and stick with your in-house, you know, this is our rule. And I've had to deal with this a lot as well. And I do find it funny. And I kind of, the way I do it is I make light of it, because for every person who posts like the European control snowfall map 10 days out, you got to understand that when you look at ensembles, there are two extremes. For every extreme outlier on the high end, there's an equal and opposite chance that the other extreme can happen. And so oftentimes I will point that out. I will say, you know, I actually made a meme one time that said, you know, only post the map with the highest totals, because that seems to be what everybody wants to do. You never see anyone post the 0-inch forecast, which is equally possible in some of these scenarios. I just think your talk was good in the fact that I felt, I don't know, camaraderie with you, because it's a struggle forecasting snow. Viewers expect an amount of certainty on something that they don't expect in every other weather phenomena. Like, I was going back and forth with a couple of my Twitter followers, like getting lost in the fact that we can't forecast amounts so far out. They get lost in the fact that we can actually forecast the chance of snow 7 days out. The fact that there's even going to be snow in our area 7 days out is a pretty big step up in forecastability. Now, that we can't nail down the totals 7 days out, you would never think about that as rain. I told my Twitter follower, I said, if I told you next week on this day it's going to rain, and it rained, no matter how much it rained, you would think I was a great forecaster. But if I tell you it's going to snow 7 days from now, and I missed the total by 2 inches, you think I suck. We don't have the same type of accountability for other forecasts. I just think snow is a unique thing, and I could get into the psychological aspects of it, but it's one of those things as a viewer, as a public, it's a tangible thing. You can go out in your yard and touch, feel. They can instantly verify your forecast with a ruler and their shoes. They can't do that with a lot of other weather phenomena, you know. So I just think it's a unique thing about snow. But Jennifer brings up a good point. It's the cat's out of the bag.
This is Dave. I just wanted to add into the mix too. Have any of you ever thought about doing a story on
We have.
meteorologists?
We have.
That you can always point to on your website, because it is impacting your credibility. And, you know, I haven't been on the air for 14 years, but when I was, people would come up to me and say, you said this, and it was somebody else
Right.
that said it. So they're not really listening, you know, and attached to you and what you said or what accumulations you gave. It could have been another station, or they could have been riding in their car, but they still associate it with you.
I guess maybe, and you can give me feedback on this. This is sort of why I turn to the preparedness message rather than focusing on how much and where, because as long as you're prepared, it doesn't matter how much you get, especially in our area where half an inch is going to cause chaos this morning. Preparedness is my message first and foremost.
Jennifer, I have in the past, and I have strict rules on my social media. I don't want, and someone puts on my Facebook a map of that or shares a map with that, I have actually shown an ensemble member the opposite. And I've gone on the air, and one time I got lambasted because I was so wrong because there was a foot of snow coming. And we got a dusting. And I said, and my station did a proof of performance, because I said, listen, everything's still on the table, this one. Please, let's be responsible. This is my quote, I'm not the first to put the map out. I strive to put the first correct map out. And I also tell people, you know, in my area, if there are a certain point in time, for you even, once it gets past that half-inch threshold, it doesn't matter if it's a half inch to 2 inches. What matters the most, and try to stress to the people, is the timing of the event. Really, it doesn't, you know, when people come, I got 6, you called for 4. Right. Well, you know what? Did it change your outcome at all? Did I tell you exactly when it was going to affect you?
Yeah, and my last thought, and then I'll hand the mic off, is you know, something that I've learned from Jim even from the early years coming to this conference is taking viewers through the process of this is an unfolding event. It's going to change, and taking them and having that discussion with them and saying, no, instead of committing to this is what we're going to get, no, watch as this develops and moves across our area, because it may change hour to hour. That's just how winter weather, even severe weather, happens. So I'm done.
Jennifer, let me add this. What I think I can do, and probably all of us, is maybe if we do a better job communicating the hazards and not get so caught up in the nitty-gritty of a 1 to 2 or 2 to 4, because as Joe said, that first quarter, half an inch on the 6th, that was enough.
Like hurricanes.
Right. Everything else was gravy on top of that, snow-wise there. And as far as the internet, wannabe meteorologists, whatever, you know, I've gone on the air and I said, hey, I know there's a lot of chatter online about 6 to 12 inches. I don't see that happening. And I'll call them out in that regard and just say, this is what I see. And I'll be adamant in what I'm thinking. But I can't ignore if there's a lot of stuff on social media where people think we're going to get a big snowstorm. I have to address that. And so I just face it head on and then say what I'm thinking.
Last question, Ken?
I don't know that it's a question. Kent Earhart from KMOV in St. Louis. You know, we've talked a lot in this conference in years past, in decades past, about uncertainty and conveying uncertainty. And the reality is that the conditions have changed since these discussions first started. What you're up against now is an iPhone that gives you certainty as a member of the public. When you pick up your phone and your opening page says 2 to 3 inches of snow, there's no disclaimer on that. There's no asterisk like we put in our text forecasts often that we post on the web that says this is a evolving situation and could go either way, could get worse, could get better, get frequent updates. There's no condition to that. There's certainty in their phones. And how many times have you been introduced to somebody at a dinner party and they say, what do you do? I'm a meteorologist on Channel 4. Oh, I don't watch local news. I get all my weather on my phone. It's right there. And it never says to me, we're not certain we're going to get 2 to 3 inches of snow. It says we're going to get 2 to 3 inches of snow. When the phone is wrong, they assume that we were wrong as well, because we're all part of that population as media or meteorologists. And so that's what we're up against with uncertainty. I, like our climatologist talked about the other night, and optimism, my personal optimism is this is still a little bit of a fad. I mean, it's obviously here to stay, but there's going to be a bell curve to it, and eventually people are going to realize that 6 or 7 words are not going to portray what's really going to happen. And I like to think that people, some amount of people are going to come back to us as local knowledge experts and realizing that, you know, everybody in this room, we're all good at what we do. It's just a matter of continuing to be good at what we do. So as people come back around and realize that they do have a source, and they can pick Cindy, they can pick me, they can pick Jennifer or whoever they want at the local level, but realize that there's going to be a calming effect, I think, in the long run. You look at anything that's happened over the span of time. I don't mean to sound like an old man like Dale here and say, hey, things happen. But they do, and I think, and I'm convinced that they're going to come back to us. Maybe not in droves, maybe not the numbers we had before, but they will, because they'll recognize that they need more than 3 words on the opening screen of their I'm done.
Ken, thanks very much. We've gone obviously a little bit over in our time, but the discussion is healthy and it's active and dynamic. Those of you who want to ask questions online, we do have an online question and answer session with Paul and also with Dr. Peter Glick, who will be talking about water and national security issues. So we're going to take a brief break, and then we'll be back here at about 10:15. So let's come back here in about 7 minutes, and we'll see you back here as well online. So stay with us, and we enjoy the discussion. Thanks.